Hello students. So today we'll continue further relation and functions. So here we'll see what is function, types of functions which we are studying in second year and numericals on those. So before defining what is function, just I will take example. There are two sets A and another set B and B. So here there are three elements in this A, B, C. There are four elements in B, 1, 2, 3, 4. I will take A is related to 3, B is related to 1. Now suppose if all the elements of first set, that is here set A, if all the elements are not related, then it is not a function. So now this relation A, 3, B, 1 is not a function because C is not related. So not a function as C is not related. C is not related. Now another example I will have A, B, C, 1, 2, 3, 4. Now here A is related to 1, A is related to 2, B is related to 3, C is related to 4. Now here what I have done? All three are related. A, 1, A, 2, B, 3, C, 4. All these three elements are related. But this is also not a function because A is related to two terms. A is related to two terms. So A, 1 and A, 2. You cannot have two images for a single element. So this is also not a function. So not a function as A is related to two terms. A is related to two terms or elements is not a function. So from these two examples you can define a function. A relation from set A to set B is said to be a function if all elements of set A are related, first condition. Second, no element of set A is related to more than one term. If it is related to more than one term, it is not a function. So now I can say A, B, C, 1, 2, 3, 4. So A is related to 2, B is related to 1, C is related to 4. Now this you can say is a function. All elements of set A are related. It is not necessary that all elements of B should be images or related to it. So all elements of set A are related. So this is a function. Or you may even say in this form A, B, C, 1, 2, 3, 4. So A is related to 1, B is related to 1, C is related to 4. A is related to 1, B is related to 1, C is related to 4. This is also a function because all elements of set A are related. So function is denoted in this form. F, two dots from A to B. Function from A to B. Now the elements in the first set are called domain are called domain, and in the second set are called codomain. Now, the set of elements which are related from B is called range. So in this first example, range is equal to set of all elements which are related. So related elements are 1, 2 and 4. So 1, 2, 4. Similarly, if I take second example here, range is equal to, so only two elements are related, 1 and 4. So range will be 1 and 4. Now, here in second year, in this we are learning three types, that is one function, onto function, and both one and onto, or you can say bijective function. Suppose if one element is of A is related to only one element of B or distinct elements, then we say it as 1. So now you can say this example as 1 because A is related to 2, B is related to 1, C is related to 4. All three elements in B are different. While here this is not 1 because A is related to 1 and even B is related to 1. So each element of set A should have distinct images, distinct elements in set B. So first one function, or even we call it as injective function, So one element of set A is related to one element of set B, and all elements from set B related are distinct. So first what I have written, you can take A, B. So A, B, C, 1, 2, 3, 4. So A is related to 3, B is related to 1, C is related to 4. So A, 3, B, 1, C, 4. All are distinct. So you can say it as a 1. Now, here in set B, all elements are not images. If all elements of set B are images of set A, then we call it as onto function. Means all elements should be related. So second one we are having is onto function. So onto function, or even it is called surjective function. So all elements of set B should be related. So if I take here A, B, C, D, here I will take 1, 2, 3. So A is related to 2, B is related to 1, C is related to 3, D is also related to 3. Now if you observe over here, all elements of set B are related to set A. Means all elements are images of elements in set A. Such we call it as relation onto function. So function we call it as onto. Now suppose if function is both 1 and onto, it is 1 and onto, then we call it as a bijective function. So here it will be both 1 and onto. So if I take A, B, C, 1, 2, 3. A is related to 2, B is related to 1, C is related to 3. Now all elements of set B are images. Second thing, so no element is unrelated, or all elements are related, and each one is related to distinct elements. So such we call it as a bijective function. Bijective function. So 1 1 function means each element of set A is related to distinct element in set B. Onto means all elements of set B are images of set A. If a function is both 1 1 and onto, then we say it is an bijective function. So you can note down, students, then we'll see numericals. Okay, students. So you can note down two problems. In short, I have written. This is based on composition of functions. So a function f from real to real, and g is another function from real to real. You are required to find f of g of x and g of f of x, where in the first one f of x is equal to sin x, g of x is equal to phi x square. So if I take first problem, you are required to find f of g of x. So f of g of x, this is nothing but f into bracket g of x, f into bracket g of x. So such functions we call it as composite functions, means f is related to g, g is related to x. It may be f is related to g, g is related to h, h is related to x. You may have any numbers. So here we are having only two functions. So f of g of x. So now f of g of x is there. So I will substitute g of x over here. So this will be f into bracket phi x square. F into bracket phi x square. So to make it easy, now I will take this as a. So I will take that one as a. Put phi x square is equal to a. Put phi x square is equal to a. So this will be f of a. F of a. Now f of x means sin x. So f of a means in place of x you should substitute a. So f of x is sin x. So f of a will be equal to sin a. Now suppose f of 30 is there, it will be sin 30. If f of 45 is there, it will be sin 45. If f of 10 is there, then it will be sin 10. Similarly, f of a will be sin a. So this is equal to sin a. Sin a. Now you substitute the value of a. So this is equal to sin phi x square. Sin phi x square. This is f of g of x. Now similarly, you can tell me g of f of x. So g of f of x is equal to, can you write first step? It is g into bracket f of x. G into bracket f of x. Now substitute f of x. F of x is sin x. So this is equal to g into bracket sin x. Now again, to make easy, you take this sin x as a. So put sin x is equal to a. Sin x is equal to a. So this will be g of a. Now similarly, how I had written over here, g of x is phi x square. Therefore g of a will be phi a square. G of a will be phi a square. So this is equal to phi a square. Now substitute a. A is sin x. Now you substitute sin x over here. So you will have find sin x bracket square phi sin x bracket square, or you can write it as sin square x. So phi sin square x. This is g of f of x. So you can pause and note down the steps. Now I will go for second one. Second, you are required to find f of g of x and g of f of x. So same technique I will be using. So along with me you too can solve, students. So first f of g of x. So substitute g of x. G of x is x raised to 1 by 3. So f into bracket x raised to 1 by 3. F into bracket x raised to 1 by 3. Now take this x raised to 1 by 3 as a. So put x raised to 1 by 3 is equal to a. So this is f of a. Now again, f of x is 27x cube. So f of a will be, very good, f of a will be 27a cube. So this is equal to 27a cube. Now you substitute this value. A is x raised to 1 by 3 means cube root of x. So a cube means it will be x. Cube root gets cancelled. So a cube is x. Directly you may write or you may substitute. So this is 27x. A cube will be x. So because a cube is equal to x from over here. So you will have 27x. Similarly, now if I take g of f of x, g of f of x. So first you should substitute f of x. So first I will substitute f of x. So g into bracket 27x cube. 27x cube. Now again to make easy, you take this 27x cube as a. So put 27x cube is equal to a. Therefore, this will be g of a. G of a. Again over here, g of x is x raised to 1 by 3. So g of a will be a raised to 1 by 3. So g of a will be a raised to 1 by 3. So we will have a raised to 1 by 3. Again from this, a raised to 1 by 3 means cube root of a. So cube root of a raised to 1 by 3 will be, cube root of 27 is 3, cube root of x cube will be x. So a raised to 1 by 3 will be equal to 3x, is equal to 3x. So again you can pause and note down the steps. Then I will go for second type problems. Second type problems. You are required to find f of x. F of x. In this first one, f of x is equal to 3x plus 2. And second one, f of x is equal to 3 minus x cube bracket raised to 1 by 3. So you can try, students, till then. So here we are having f of x. So if I take first one. So first one, you are required to find f of x. So this is nothing but f into bracket f of x. Now substitute f of x. F of x is 3x plus 2. So f into bracket 3x plus 2. Now again to make easy, you take this as a, means it will be easy to solve. Put 3x plus 2 is equal to a. 3x plus 2 is equal to a. So you will have f of a. You will have f of a. Now f of x is 3x plus 2. So now f of a will be Very good. 3a plus 2. So this is 3a plus 2. Now substitute the value of a over here. You will have 3 into bracket. A is 3x plus 2 plus 2. If I simplify, you will have 3 into 3, 9x, 3 into 2, 6 plus 2. That is 9x plus 8. 9x plus 8. This is the first one. Similarly, now we will try second one. Second, f of x is equal to f into bracket f of x. F into bracket f of x. Now substitute f of x. F of x is 3 minus x cube bracket raised to 1 by 3. So f into bracket 3 minus x cube bracket raised to 1 by 3. Now I will take this one as a. So put a is equal to 3 minus x cube bracket raised to 1 by 3. Put a is equal to 3 minus x cube bracket raised to 1 by 3. So this will be f of a. F of a. Now again, f of a will be 3 minus a cube bracket raised to 1 by 3. So you will have 3 minus a cube bracket raised to 1 by 3. Clear? So if I substitute in this definition, you will have 3 minus a cube raised to 1 by 3. Now again substitute a or a cube. So if a is equal to this, then a cube will be equal to this cube root gets cancelled. You will have 3 minus x cube. So if you take a cube, this cube root gets cancelled. You will have 3 minus x cube. So I will substitute that over here. This is equal to 3 minus. Minus a cube means this will be minus, this will be plus. So minus 3 plus x cube bracket raised to 1 by 3. Now plus 3 minus 3 gets cancelled. You will have x cube bracket raised to 1 by 3. Cube and cube root gets cancelled. Answer will be x. You will have answer x. This is the second type problems. Then we will go for third type. You can note down those, students. Third type, G function f to f, real to real. G is from real to real. You are required to find. So third, he has given f of x as modulus function and g of x as greatest integer function. As greatest integer function, you are required to find f of g of minus 1 by 2 plus g of f of minus 1 by 2. You are required to find f of g of minus 1 by 2 and g of f of minus 1 by 2 and add both. Now, before solving problem, how we take greatest integer function I will be telling. So greatest integer function. So now g of x is there. G of x is equal to greatest integer function. So now just you take a number line 0, 1, 2, so on, minus 1, minus 2. So this denotes integer just to the left of a given number. Integer to the left of a given number. Now for example, if it is 2.33, So 2.33 will come over here, 2.33. So integer just to its left is 2, so its answer will be 2. Answer will be 2, just to its left. Suppose if it is 1.99, 1.99. So 1.99 you will be having over here. Here you will have 1.99. So 1.99, integer to the left of this is 1. Don't take as 2. We are not rounding off. We are taking integer to the left. So its answer will be 1. Similarly, if it is minus 0.5, minus 0.5. So minus 0.5 you will be having over here. So to its left integer is minus 1. So you will be having minus 1. Clear, students? Okay. Now we will solve these two. First I will find f of g of minus 1 by 2. F of g of minus 1 by 2. So this is nothing but f into bracket g of minus 0.5. Minus 0.5. I have divided 1 by 2. G of x. G of x is nothing but greatest integer function. So just here I told minus 0.5 means its value will be equal to minus 1. So here I have written. So minus 0.5. Greatest integer will be minus 1. So value of this. So I will be writing steps over here. So g of minus 0.5 is nothing but greatest integer of minus 0.5, and that is equal to minus 1. That is equal to minus 1. So I will substitute now in this. So therefore f into bracket minus 1. F into bracket minus 1. Clear, students? I have simplified this. G of minus 0.5 is greatest integer minus 0.5. Greatest integer of this value will be left of minus 0.5. So left of minus 0.5 integer is minus 1. So this is minus 1. Now f of minus 1. F of x is modulus function. So modulus means mod of minus 1. So in modulus we take positive. So this is 1. So f of g of minus 1 by 2 is 1. Now similarly I will take g of f. So g of f of minus 1 by 2. This is nothing but g into bracket f of minus 0.5. Minus 0.5. Now first I will calculate f of minus 0.5. So f of minus 0.5 is equal to f of x, he has given it as a modulus function. So mod of minus 0.5. Mod of minus 0.5. So mod of minus 0.5 will be 0.5 because modulus means we neglect negative or it becomes positive. So now g of f of x. So I will substitute g into bracket. This value is 0.5. 0.5. Now g of x is the greatest integer function. This is equal to square bracket 0.5. Denotation for greatest integer is square bracket. You have studied it in first year. Now again if you observe over here number line 0.5 you will be getting over here 0.5. So integer to the left of 0.5 is 0. So this answer will be equal to 0. Now you add both, you will get the answer. So therefore if you add both, therefore f of g of minus 1 by 2 plus g of f of minus 1 by 2 will be equal to 1 plus 0, that is equal to 1. That is equal to 1. Clear, students? Similarly, you can try in your home, find, so terms remains the same, that is f of x is modulus function, g of x is greatest integer function. You can try f of g of minus 3 by 2 plus g of f of 4 by 3. G of f of 4 by 3. This you can try on your own. Again, in next session,